Right. Hello and welcome everyone. My name is Abhishek. I am a senior engineer at Orkes and I work with Oliver. It's lovely to see so many of you attending today's presentations. All right, so I'm going to talk about building distributed applications using Python. And I'm going to continue from where Oliver left. And instead of working with the UI, we'll actually go high code. So that's the USP of Conductor. You can actually go as high code as possible. So the agenda would be, first I'll give a brief introduction on SDKs and microservices in general. You all are developers, so you must be pretty familiar with these concepts, but I'll give a refresher anyways. Then we'll try to build a real world kind of app, specifically a distributed cab ride booking app. And then we'll dive into the action, we'll do a demo, and then I would leave some time for the questions, but feel free to interrupt me at any point in time. Yes, we are recording this. And we'll probably edit it and share it later on social media. Cool. All right. What can we do with the Conductor SDKs? What are Conductor SDKs? Or rather, why do we need an SDK? Does anybody have any idea? I'm sure people have. It's basically a set of toolkit that you need to develop on a top of a platform. Conductor is essentially a platform. So think of it as a layer between cloud and your applications. And in the process, it actually empowers you to build distributed applications, agnostic of the cloud, agnostic of the tech stack. We take pride in saying that we are a polyglot platform because you could potentially have microservices running using different technologies in different clouds. You could have a Ruby on Rails app running in AWS. You could have Golang service running in Azure, a Python service running in GCP, and we can still find a way for them to interact with each other without you doing complex system designs. So we support Python, we support Java, we support Golang, TypeScript, JavaScript, C#, and believe it or not, we also support Clojure. And I'm not the one who maintains it, so no questions on Clojure. Now, Conductor has a rich set of functionalities, which includes managing workflows, tasks, like Oliver showed. In addition to that, we have an enterprise version of Conductor, which is Orkes, where we work. And there we support richer functionality, for example, management of permissions. Oliver just showed you how to create an application associating with a user, that kind of stuff. We have stuff like schedulers, which are essentially crawls that you can put in place and run workflows periodically. You have secret management. We have recently added support for AI integrations. So if you have a Gen AI model, have a vector database, you can actually connect it to an Orkes workflow and run some interesting AI workflows and build your own chatbots. We support integrations. So all of this, you can imagine, so much stuff is going on. You need a way to programmatically access all of this because a lot of our users are actually developers. Now, everything cannot be accessed using API. I mean, it can. We do have APIs for everything, but every developer is working in a different language. So there comes the SDKs. We try to maintain parity between all the SDKs. We try to maintain parity between SDKs and the platform itself. So whenever we add a feature, we add a set of APIs, we add them to the SDKs. So today, I'm going to highlight 3 important things that you could do with an SDK, specifically the Python SDK. We define task workers. So Oliver talked about tasks and workers. So we'll actually define the task workers. And task workers is essentially the pieces of code which are actually running in your microservices and talking to Conductor, which is the orchestrator. We create workflow and task definitions from the code, just like Oliver created it from the UI. We'll actually do it from the code, and then we'll actually trigger the workflows. And having said that, so these are links to our PyPy package, Conductor Python. We recently released 1.1.x, so feel free to play around. It's perfectly compatible with Conductor OSS and Orkes both. And on the right, there is the Conductor Python GitHub repo. let me actually show you the repo itself. So this is the Conductor Python repo. Contributions are welcome. We actually have had developers recently contributing both from the community and actually from our customers. So we are open to contributions. We totally believe in collaboration. We actually have Conductor channel, which has 1,500 people in it. We also have dedicated channels for each language. So whenever you have a question, you can pop in the question and somebody would definitely respond. Or you will create GitHub issues as well. So this is the repo. This is pretty exhaustive. It has installation instructions set up. It has out-of-the-box examples demonstrating different kind of capabilities, different kind of workflows that you can build from code. And yeah, so if I have to go to the examples repo, you can actually see a bunch of examples here, which we have tried to be as exhaustive as possible to cover as many features as we can, both for Conductor and Orkes. And now I'm going to show you a snippet from these examples, and then we'll actually run it as well. So this is the only piece of code you need to actually write to build a very, very small app on your machine which talks to Conductor. That's it. That is it. So you can literally spin up an app in a matter of seconds. So let's just go line by line. So the first snippet is to write a worker, which is the unit of work that will be done by a task, which is called greet. So in here, I'm using this decorator called worker task. I love Python decorators, by the way. I think it's just so powerful. So I import worker task. I just give it a task definition name called greet. Now what this means is I'm trying to create a task on the fly called greet. And I just define the function name. I put in the input. You can put any number of inputs. It will automatically create a task with that number of inputs. And then I just have a return statement here. Now, technically, you can put as much business logic you want to between that definition and the return statement. It could be database calls, it could be third-party integrations, it could be validations, it could be all sorts of stuff. So that is what you need to actually just create a worker, which would be essentially running in your microservice. Next step would be to actually create a workflow definition. So just as Oliver was creating a workflow, putting in a task there, naming it, this is essentially what we're doing here. So we have a couple of utility classes here, which we use for a Conductor workflow and workflow executor. And then if you notice, I'm actually importing greet, which was the worker function I defined. So I'm reusing the code here. I create a workflow called hello. So this is like a hello world for Conductor. And then I use an indirection operator to just put in the task inside that workflow. So if you would put 5 tasks using 5 sets of indirection operators, you'll end up with a workflow of 5 tasks in that sequence. And here I'm just creating like a simple task, but you would actually put any kinds of tasks you want to. Then we just call workflow.register. This will create the workflow definition in Conductor. And lastly, you want to execute the workflow, you just instantiate what we call a workflow client. This is introduced in the latest version, and you just start the workflow by name and pass the input. So it is as simple as that. So let me show you things in action here. So let's go to VS Code, right? I'll read the font just in case. Right. Okay. So I showed you the repo of Conductor Python. I opened it up here, and there is the examples here. So the snippet that I showed you was for greetings. So in this, everything is laid down. So I'm just going to run this. So this created the workflow, this spun up the worker, this executed the task, and my workflow should be present somewhere here. All right, so this is a test environment that I've been playing around with. And if you see, let's just filter on hello. And a workflow called hello was created. The task was greet. the input was Orkes, that was hard coded, and output was hello my friend Orkes. So it was as simple as that to create a full-fledged workflow, including the task. All right. So now that we have done that, so I'll take a pause. Any questions so far about any of it? Cool. So let's take it up a notch. So we built a very, very simple hello world kind of app here. Now, you would obviously use Conductor for much more powerful things. So let's try to build a distributed app in real time. And in this particular scenario, I will build a cab ride booking app. So just like Uber or Lyft, how would the basic workflow look like? You will book a ride. You will assign a driver to the ride. You will set up a payment. You will try to make the payment. And then you'll send the notifications to the customer and the rider. For the purpose of the demo, we are not focusing on the cab ride itself. We are just focusing on the booking part of it. Now, by just looking at it, you could presume that there is a microservice running behind each of these functionality with its own database, with its own validations, with its own API calls, and a lot of other stuff going on. Probably every service or suite of services has a team building that service in some language, in some technology. Could be the same, could be different. But essentially, you would at least have 4 microservices. And then the app server, where the mobile app calls the server and then distributes the work. So how would you potentially do such a thing? Microservices. Now, when Oliver explained the evolution of building software over the years, it brought us to this moment in time where we are in this world where everybody's moving towards microservices, and even they're moving back to monolithic architecture. So we have really made a lot of advancements and back. Now, there are different kind of design patterns for microservices. We have API gateway, we have CQRS, event-driven architecture, Saga, Strangler, and a bunch of this. I'm not an expert here, so this is not an exhaustive list, but these are the names that you must have heard at some point in your career. Now, microservices allow you to segregate your data, give you the flexibility, scalability, failure isolation, compartmentalization, but then it comes with its own challenges. Now, one of the biggest challenges when you are working with microservices is orchestration. So this is an attempt for us to show you how you can actually use Conductor to solve that particular problem. So I will be demonstrating Saga pattern while building my cab ride sharing app. So for those who don't know, Saga basically solves the problem of distributed transactions. So let me go back to my workflow here. So you book the ride, you assign the driver, and now for some reason your payment actually failed. Then what happens? You have to undo everything. Now you have different microservices running, which are doing its own thing. And now at some point, something has failed. Now what do? If it was a monolith, yes, it's simple. It's a transaction. It's taken care of. But it's a microservice, you run into a bunch of issues. So how do we solve that? We can employ the Saga design pattern. Now, Saga's advantage is that it allows you for distributed transaction failures, but the very pro becomes a con because implementing that is a huge challenge, especially when you have like tens and hundreds of services. So you can do the orchestration in 2 ways, rather coordination in 2 ways. Orchestration is one of that. There is choreography-based Saga, where there is no central coordinator, but the services have to be aware and talk to each other and find a way to do the rollback. And then there is orchestration-based Saga, where there is a centralized orchestrator which actually takes care of the rollback. And Conductor, because Conductor is the underlying platform here at Orkes, perfectly fits for this job. The reason is this. We don't need to communicate with each other, and when I say we, basically it's the microservices. When there is a centralized system like Conductor, which is actually taking care of the communication, debugging logs, retries, state management, failure management, performance management, everything. And that's why we're going to build this app using the Saga pattern. And let's see it in action. So let me now dive into code. Okay, this will be heavy code, so brace yourselves. Okay, so I have spun up this repo called Conductor Examples Python Cap Saga. This is available for cloning. I will share the link later in the slides, so you can go ahead and clone it after the talk. All right, so I go through the structure here. I'll actually go in the repo and show you because it will be a little better in terms of brightness. So I have the services folder where I have put all my microservices. I have a Docker file. I have a Docker compose file, which basically is used to spin up the various microservices. So I'm trying to emulate a production-like environment where you probably would use Kubernetes to spin up your Docker containers. I have a main, which basically runs my server. I have a requirements file for installing dependencies. I have a workers.py, I have a workflow.py. So we're going to do three things. We'll create the task workers, we'll create the workflow, and then we'll execute the actual code. So let me take you through the services that we have. So like in the diagram, like in the workflow, we start with the booking service, then we have the assignment service, then we have the payment service, and then we have the notification service. These are not talking to each other, they're just independently running wherever you want them to run. So if I go to booking services, I have a very simple file called booking.py. Here I have three functions: book write, confirm booking, and cancel booking. The names are pretty clear. They are used to do those respective functions. I'm just hard coding, so any booking created will have the same ID for now, and same with confirmation booking, same with cancellation booking. But like I said before, you could put any business logic in between. And you just put this code and plug it in to your microservice. And then for every worker, you have a main, because obviously you need to start the worker. So I just go through this. Is it big enough, people? I can. It's fine. Okay. All right. So this is the only piece of code that you need to write in addition to that worker. So I instantiate a configuration object. So in Python, what we've done is we're doing a lot of magic behind the scenes. So we just set up a bunch of environment variables like whatever I showed you, and the configuration object automatically picks it up. So you just need to instantiate this object, pass it to, actually in this case, I'm not, yes, and pass it to the task handler. Task handler is a class which is used to spin up the workers. So as many workers you want to, you can spin up. Here I'm saying import modules, okay? So that basically means in the current folder structure, import the modules called booking. I can import a bunch of modules also. And then it'll automatically detect what the function that you're defining and treat them as workers. That is it. So I have a main for every service, but you could potentially just have everything in one file. So this also works for a monolith, obviously. So if you have, suppose I have a workers.py on the root. Here, what I've done is imported all these modules. So if you want to run this as a monolith, you can do this. All right. So those are my services. So now let's go to the code again. Any questions so far? Am I going too fast or everything is good? Cool. All right. So let's go to workflow.py. So this is a script that I've written, which basically will allow you to create a workflow on the fly. Simple main, we call this method, and the interesting part is this method itself. Okay. So let's go line by line. I instantiated this configuration object, as I showed you before, another utility class instantiated here. And now in line number 16, I'm actually creating a workflow in memory with this conductor workflow object. I'm going to say name it something. Boston GDG. All right. Then I create the first task in the workflow. I call it book write. And if you see, I'm just importing it from the workflow that we do. So you have a microservice, you implemented the workers, and now you can actually, when you're building the workflow, you can actually import them as libraries and just use them directly. This is safe, it's easy to do, you exactly know what you need to import and what you need to use in your workflow creation. I give reference name here. So we have two things, task definition name and reference name. Definition name is the type of task and reference name is what instance of that task within the workflow. Because you can potentially be doing the same thing again and again, but we need a way to identify what is what. So that's the reference name. So in this case, I just have one book write task, so I will give it this reference name. And now, because this is the start of the workflow, I need the input that was passed to the workflow. So you have your mobile app, you are requesting a ride. So in the API, potentially you will pass the rider ID, you will pass the pickup location and drop off location, but the task needs it as an input. So as long as it is defined in your workflow, as long as it is passed in your workflow, this guy is saying, just give me from the workflow input and pass it to the book write. The next step is assigning the driver. Now, the driver task needs a booking ID. A booking ID was created by the book task, given back to conductor. Conductor told the assigned write task, you know what, book write has happened. I'm giving you a booking ID. Now go ahead and do whatever you want to do. And then once you're done, let me know. So I can pass book.output booking ID. So dynamically, whatever the booking ID comes in, it'll pass it to the assigned driver task. And this flow will continue. We'll do the payment. And by the way, you could refer the input and output of the workflow or any previously executed task at any point in time. So all that execution data is always available during the run of the workflow. And then you confirm the booking, and then you want to send the notifications to the customer and the driver. So what I do here is I create a fork tasks. So we support a fork task where you can do parallelization. I think Oliver did show you something like that. So in this case, I want to send notifications to both the driver and the customer. So I create a fork task with both of them. And I also mark them as optional because they are not mission critical. Even if the notification is late or something, you should still go on with the write. And now, so we touched upon this before. So final putting of the pieces together happens like this. You have the workflow and then you put the tasks in sequence. All right. And you set up the workflow input parameters, like I mentioned before. As long as you have specified those inputs, those will be accessible to all the tasks in the workflow. And then finally, I specify the output of the workflow. And I call this piece of code, and it registers the workflow definition. So let's run it, and let's see this in action.
So it's like 61 happening sequentially. Like
Sorry, once again.
It's like 61 happening sequentially, like one ends and the next one starts.
61 is happening at once. So it's behind the scenes, yes. So yes, there are 5 function calls behind the scenes.
Right.
Indirection operator is being invoked 5 times.
Right, but I was thinking that if it doesn't happen sequentially, then how can pay happen even if the booking has not?
Yeah, that's what. Yes, exactly. It is happening sequentially. So you need to specify the right order here.
Okay.
Otherwise, it will not create it in the right order. Okay. So yeah, that is correct.
Just a second.
Yeah.
So how does the communication happen? Is
Yeah.
it socket based or
Yes.
a long polling, or how it is handled between the conductor and the microservices?
So basically, the workers run. They are depending on the language, they process all threads, and they just poll continuously depending on the polling interval you specify. I think the default is 500 milliseconds, and they continuously make polling for data. It's an actual API actually. Call the poll API, then it call the update API also.
So it's HTTP long polling API, right?
Yeah.
Okay, thank you.
Cool. So let me actually run this script. So I have a main here, so I can run the script. Sorry. Also, goodbye. Okay, so let's go and see if it actually created something. Okay, so it created. It's always good when things work. So this created a workflow. As expected, book ride, assign driver, make payment, confirm booking, sending notifications using a fork, and you can see there's a join task at the end, which basically joins the two forks. So that is the workflow definition created purely by code. Any further questions on this part before I move on?
So in a typical scenario, what you would do is broadcast and then wait for the driver to respond, right? So
Yes.
is that,
That's not happening here.
I know it's not happening, but is it doable in kind of the workflow that you can create in Orkes?
Not from a worker perspective, but you can publish events and stuff from Orkes. You can. We also have CDC, so you can listen to those events on external queues. So that kind of thing is supported in Orkes. But the polling mechanism today is not push. Today,
Correct.
I'm not saying it's not doable,
Okay.
or we have not talked about it. We have definitely had conversations around it. Yeah.
Thank you.
Great question. All right. So I showed you how to create a workflow. I showed you the different services, and now let's run a full-fledged app. The last piece in this is I'm going to spin up a small Flask server, which basically exposes one endpoint to create a booking, and just in case I am going to register the workflow definition again, because I just used the script to show you, but in reality, you might want to make sure the workflow is created. So we'll call this API, the SDK method to register the workflow definition. And then I will take the input from the API request that I'm getting in this server, and then call the conductor server to start this workflow. All right, so let's do it. Okay. So my server is running on port 5000. I'll just quickly go through my Docker compose file just to make sure everything is set up properly. So I'm going to spin up my 4 microservices on different ports using Docker 5001, 2, 3, 4. Now again, I could have simply run this workers.py file and it would just run on one port. Not even on one port, it would just run and poll, for example, like this. So if I would do this, yeah, so here you can see the logs. So it's basically polling for all of these tasks. I could have done that also. Okay, so let's do the Docker way. I'm gonna build my containers here. All right, my server is up, and now I'm going to make an API request. So this is Postman. Okay, so let's specify the pickup location, some random address, fictitious address in Chicago, same with the drop-off location, and I pass the writer ID as well. To make this API request to my local server, let's go back and see. So if you can see, a post request was accepted on my Flask server, and let's go and see if a workflow was created here or not. Yes, so CAP service, Saga, Boston G2G, workflow was executed, a ride was created with the input as the pass location, the rider ID, output was given to booking ID, driver assignment got an input of the booking ID, it gave back the driver ID, payment happened, input, output, confirm booking, and then notification was sent at the end. One thing that we could potentially do is we could also add logs when we are implementing our vocal logic for debugging purposes. See, I think Oliver touched upon this. I have not added them here, but we could add logs as well. So that is a successful execution of the workflow. So before I move on to this slide, any other questions on the code? All right. So what did we exactly build here? We have a cab booking app which makes an API call to a web server. This web server tells Conductor, I have received a request. Please go ahead and start a workflow. Conductor starts a workflow, and in parallel, we have all of these microservices which have Conductor workers running in them, polling the Conductor server and asking for work. And as you can see, there's no communication absolutely happening between any of the artifacts, any of the services in your application. So this is the basic architecture of what we developed. Now I want to talk about, we talked about Saga distributed rollback, but we have to see that in action. So how could we encounter failures? Now, a potential scenario is that something fails. And in this example, let's take payment fails. So how can we demonstrate that? So let's go back to the code and let's go back to the payment service. So in payment service, I have this hard-coded logic. If the rider ID is greater than 2, then just pay the payment, thereby demonstrating that the credit card is probably not added for that rider. So if I pass the rider ID as greater than 2, then it should fail the payment. All right, so let's, I have another input here. So I'm going to pass this. All right, so let's go back and let's go to executions. Let's look at this one. So yes, indeed, the payment failed. This was the input, and output was payment status failed. Now, how you could deal with this in Conductor is using this. Sorry for jumping around. So I don't know if you noticed this in the workflows file. There was this line called workflow definition.failure workflow. So this is a pre-created workflow. I created it before by copying a JSON from another environment. Answer one of the questions. And now what I've done is I've specified in this, if there's a scenario where this particular workflow fails, then call this workflow or execute this workflow. So let's go back and see if this workflow was called. Yes, it said triggered failure workflow, and this workflow was called. Now, what is happening inside this workflow is it takes the input. So whenever a workflow fails, it actually takes the execution data of the previous parent workflow. It gets that as an input, and I have a simple JSON transform task, which is like a system task, where I try to parse it and understand at what step did I fail. So if I go to the input is this, and the output is this task fail, mean payment ref. Now this looks complex, but if you were to just to see the workflow definition of the cancellation workflow, it's not that complex. So it is this, that's it. So this is my parsing logic, which basically takes the last task name, which was executed. Right, back to this. Then I have a switch construct, which is like a programming construct where you can evaluate on decision cases. I have a default case which directly goes to cancel booking when you don't have any more information. If it is a driver assignment failure, then you cancel the driver assignment and then you cancel the booking. So basically you execute transactions in the reverse order to realize the Saga pattern. If the payment was failed, which it did in this case, you will actually cancel the payment and then you will cancel the driver assignment and then we'll cancel the booking. And then additionally, you would probably want to send the notifications telling the rider and the driver that the booking has been cancelled. And so that is it for the code and the demo. Again, I'll take a pause before discussing the summary. Any questions? What you saw?
I do have a question.
Yeah, go ahead.
Last slide.
Yeah.
In the last slide where you were talking about the workflows, do you go to that slide? No. The most recent one where there was like the failure workflow. The failure workflow.
This is the failure workflow. Maybe you wanted to actually see the failure workflow? Yeah.
Yeah. So here I see like the cancel driver assignment has like two instances of it, the two similar tasks. I'm curious why we use two different tasks as opposed to like using one task and routing the process to it directly.
So you're saying optionally run a task. So yes, so it's a great question. So interesting thing about Conductor is you can actually solve the same problem in different ways. So if you can find a way to do what you just said, you can actually do it. So let me think about it. So in that case, what I would do is, it's just that the cancel driver assignment logic would be more thinking. So you cancel the payment. And then you want to directly come to cancel driver assignment there. I think you'll have to probably have a switch within a switch, that kind of a thing. Or could you think of something like that?
Or sub workflow.
Or call it sub workflow, yes. So that's another good point actually. So you could call it sub workflow. So you can have another sub workflow which is doing something based on its input. So you could call sub workflow which is saying, okay, if the payment cancellation is necessary, do it, otherwise don't do it. You can make an optional task. So yeah, you could do something like that. It is just that I implemented this because it is more clear. Yeah.
I have one question. Like at the payment, once it is getting cancelled, so can we add some another element over that which we try to retry out the payment and back the workload to the upper one, so that the user can again use the other credit card and try the payment again?
Yes, you can do that. So we do support a construct called do while, which is basically like a programming construct. You can go back in time. You can go back a task. You can actually do a bunch of things from here as well. So you could have these different branches, and within that, you can actually do a lot of stuff that your microservice is doing. For example, it's probably canceling a transaction at a database, calling a third-party API. So you could do all of that. So you could have like a lists of tasks that you would be doing. But yeah.
So we can roll back it over that and again.
Yeah. You can go back and retry. And plus, we also support retries ourselves. So every task has a retry specified. So let me just go to the workflow definition again. Okay, so I think by default, so if I go to task definition here, because those were dynamic tasks, they were not created. But suppose I have to create a task here which I want to reuse across the different workflows, I can actually create a task here. And then here I can set up timeouts, I can set up rate limit settings, a retry setting. So by default, we normally have a retry of 3. And then you also have a delay that you can specify between the retries.
Yeah.
More questions? Yeah.
So, are we expecting the microservices to get developed in one programming language, or one can be in Java and one can be in Python?
Yes, one could be on Java, running on AWS, one could be in Python, running in GCP, one could be in Golang, running locally, and they'll find a way to communicate with each other through Conductor.
Okay, so the conductor code will communicate with all these microservices and it will do the workflow.
The reverse, yes. To a gentleman's question, for now, the way it works is the worker code communicates with conductor
Okay.
and asks for work. So, and actually, on that point, I'll show you something here. So we have a queue monitor, which actually shows you the workers, which actually the tasks which have work pending. So you could actually have applications which are drawing insights by calling this queue API. So you can actually know how many tasks are there in the queue. So if you want to scale like on the fly, you have EKS, you have Kubernetes, Docker, and you want to scale your resources because there's a lot of work coming in. You could actually use this API to poll for the queue status. And also, when a workflow is executed, I'll show you one more thing. So here, if you notice, there's a worker name. By default, because I'm running the Docker container, it is taking the Docker container ID. But you can actually specify a worker name. So you will exactly know where the worker is running. You will potentially have, I don't know, QA, book write, instance 1. So that will tell you this worker is running in the QA environment. That kind of thing.
I think you alluded to my question that I was going to ask is, does the platform take care of some of the characteristics of a distributed system, like if I have to do auto scaling, if I have to do other things like security, whatever? How much is it done by Orkes versus where it's actually running? So if I'm running it on Kubernetes, I think it's my responsibility to kind of look at what's happening in the platform and trigger some events, or how does it work? Or does Orkes provide any help? Because as a distributed system, I don't want to worry about any of the utilities.
Yeah.
So
that is a great question. So it's a combination. So first of all, we come in multiple flavors. We could be customer hosted or we could be Orkes hosted, which means the Orkes instance is running in Orkes cloud. And in the case of customer hosted, the Orkes instances are actually running in the customer cloud. So that is the background. Secondly, the workers that you are running on your end, they'll always run in your infrastructure. They will never run on our infrastructure. So scaling those are always the responsibility of the developer or the customer. But scaling of the Orkes servers, if they are hosted by us, then we support that. So, but that's more like in coordination with the customer. Like if their workflows are increasing, so the throughput going to like 1,000 per second, and we're creating millions of workflows, then it's very easy to kind of scale the resources. But auto scaling, no. But we don't auto scale. That was the question.
thank you.
Sure, the metrics.
Was that
Ensure the integration is proper.
integration with?
The metrics.
Oh yes. I would like to show one more thing. That's a good point. So we do have this one doesn't have it, but let me just show you. So we do have integration with Grafana. So you can see the health of all your workers, workflows, tasks here, and you can actually set up alerts to your alerting systems. Say Opsgenie, PagerDuty, and we do also have. We have actually added tasks within Orkes, not Conductor, to actually query this data. So within the workflow, you can actually query all of this data. So this also kind of helps with that. And we are actively working on insights dashboard within the platform. So that will actually give you the health of your workflows, tasks, and how many are being created, that kind of thing. Cool. So what we learned, we basically built a distributed application using the Python SDK. We also saw how we can use Conductor as a centralized orchestrator. When you're doing a Saga pattern, you can adapt Conductor for any kind of system architecture because it is pretty flexible. In this scenario, we saw how we could deploy the Saga service pattern. And we also saw a distributed rollback using the failure workflow feature that we have. And I've also shared the GitHub repo right at the bottom there. So feel free to play around. I have all the instructions there, how to spin up a server on your end. Yeah, and yeah, that is it. Any